Welcome to our YouTube channel. In this video, we are going to do design of substation gantry structure in Eurocode with STAAD.Pro. This is a first stage of out of 3. In this, we are going to apply the primary loads to the gantry structure model which we had developed earlier. For how to develop gantry structure model in STAAD.Pro, we had given a video in this our YouTube channel. The link for the video is given in the description. Also, the calculation of this 19 numbers of loads except the 20th minimum temperature load on structure are well explained in our previous video. The load calculation video also available in our YouTube channel. The link for the same is provided in the description. So before going to watch this video, we request you to watch our modeling video and the calculation of the loads for substation gantry structure. Let's apply the primary loads which we had calculated earlier to the STAAD.Pro model. This is the model which we had developed earlier. The detailed demonstration how to create the model in STAAD.Pro is well explained in our previous video. The link for the video is given in the description. You can look into that before coming to watch this video. So this model is having a 2 bay. What we are going to do is we are going to delete 1 bay and we are going to apply the loads on 1 bay. After that, we can copy paste the same thing for 2 bay. Because applying for both the bays, it will take more time. Select and delete the second bay. So now we can see only 1 bay. First of all, we are going to apply the calculated loads on conductor fixing and earth wire fixing nodes. So select those views alone. You can again select only the face-to-face distance point and the tower peak. So these are the points which we are going to apply the loads. We have also calculated the loads on substation gantry structure earlier. The video about how to calculate the gantry structure loads are here in our YouTube channel. The link for the video is provided in the description. You can also have a look about that. So these are the loads. There are 20 number of loads. Out of that, we had calculated 19 number of loads. The video you can watch before looking into this application of loads into the gantry structure model. So there are various methods we had seen in that video about the calculation of these loads. So now we are going to look into that summary of those calculated loads, and that summary value we are going to apply on the model which is showing here. So you can see there is a dual screen. One is in the left hand side, it's a STAAD.Pro with the model, and in the right hand side you can see an Excel sheet which we had calculated the loads with a summary. So these are the summary value which we are going to apply here. So before that, we need to create the load descriptions or load names or load types we have to create. You can minimize this. So go to loadings. Here in the load cases details, you need to click new, and the load case we are going to define the same name which we are providing here. Dead load without ice is our first case. Dead load add. The second case is dead load with ice add. So similar like we have to do for all the loads. So this wire tension we can have it in live load type. So next is a wind. Load case 10 is also wind. After adding all the wind load calculation, wind load cases, next is a short circuit forces 0 degree. So we can add this into accidental load or anything different than that wind, and yeah, accidental we can add it. Short circuit also, short circuit force in 30 degree also accidental. Next one is minimum temperature. So this load case we can consider as a temperature load. So now you can see here in the load and definition list, there are 20 load cases are listed, which we are having in the Excel sheet. Now we need to feed the values inside each load cases. So select first one, dead load without ice, and in the Excel sheet you can see the summary values. Click add. So here we need to add the sulfate. So for structure we can add y direction -1. Next we need to add the nodal forces for earth wire and conductor. So click on node. So as you see in the Excel sheet, for horizontal force f of x, which we had calculated, for STAAD we need to apply it in f of z, and in horizontal force f of y we have to apply in f of x. Here the f of x direction means which we had calculated, the value are in the direction parallel to the conductor span. So in this STAAD.Pro model you can see this is the conductor span direction, whereas in the left bottom corner you can see that z direction is the direction which is parallel to the conductor span. So what we have calculated f of x is the f of z in STAAD.Pro, and f of y which is calculated is to be f of x. Similar for vertical f of z which we had calculated is f of y. Here in the left corner of the left bottom corner of the STAAD.Pro model you can see y axis is in vertical direction. So likewise we have to feed our input. So in the first case, dead load without ice, we are having only vertical load. So that is f of y we need to enter. F of y we need to enter in minus because it is a downward force. We are having two values. For girder it is 11.85. Adding this by pressing enter in the keyboard. You can see here in the load and the definition window also. Now again we need to add 12.85, and for tower structure at the top of tower we need to enter 0.3 kN. minus 0.3 kN. So you can see here the load intensity are in kips and kilo inches per second. We need to change this first of all before that. So we can go to that specification. So go to geometry, click this unit inputs. Here it is in English unit. We need to change this into metric, meter, kilonewton, apply. So now we can go to loadings. Here the units are changed into kilonewton and the value also changed according to that, but we don't want this. We need to change these values also. So here instead of minus 52, it should be 11.82 kN. Again here minus 12.85. .3. So similar like we need to add for dead load also, dead load with ice also. So in this case, sulfate we can add it as 1.2 for structure, considering the ice load also. So this is added here now. Next one is nodal load. We have to add similar like we did for dead load without ice. So here it is minus 13.01. And for mid phases also the same value, because during icing there won't be any maintenance, there won't be any person standing on the girder midspan operating or doing any maintenance activities. So there won't be any 1 kilonewton which we are considered for dead load without ice. And similarly for tower peak, 0.96 is the load value. So we had entered dead load and dead load with and without ice. Now we are going to apply wire tensions respectively as per the calculated summary value. So similarly we need to add all the summary values. So for wire tension, add nodal load as f of z 20, and for tower peak it is 5 kN. Next case, add nodal forces as 30 and 10 respectively. So in the sixth case, there should be nodal loads in all the three directions. So 15 is f of z, and for f of x it is 8.67, f of y vertical it is 10. Similarly for tower also we need to add it. F of z is 3.75 and f of y vertical is 2.5. F of x is 2.17. So you can see here those values. Similar like we need to apply for all the other 7 and 8 cases. So we are applied wire tensions up to the load case 8. Next one is the wind load cases, start from 9 to 17 we need to apply. So there are certain cases for extreme wind cases, that is 0, 45 and 90 direction. So we are going to apply f of z and f of x. So in that 0 direction, nodal load, nodal forces, so it is 3.21 in f of z, adding, and in earthwork fixing there is no loads. Next one is extreme wind in 45 degree. So in that there are 2 direction loads. F of z is 2.27 and f of x is 4.95. And for extreme wind 90 degree, the nodal force values is 7 in f of x. Also we need to add that tower forces also, that is node f of x 0.82. Similar like for 45 degree also we are having a load at the tower top in f of x, that is 0.58. So we had added the values of extreme wind. Similar like we need to add for high and moderate wind. So far we had added all the wind load values also. The next one is short circuit force we are going to add. So this is also going to apply like wire tension. Nodal force, f of z, it is 70. And for tower peak it is 5 kN. Here we had considered only the wire tension of the earth wire instead of short circuit force for earth wire alone, because that earth wire is not subject to any short circuit forces. Similar like for 30 degree short circuit force also we need to add. So here you can see there are 3 directional forces. So here we need to point out the nodal reference. So now this 11.82 we know that it should be applied in the n phases. You can click this toggle load and click one by one the node. Select here node cursor, assign. So you can see it is applying downward. We can apply any nodes, either it should be in this side or that side. So we had applied for end phases. So as we know that calculated value for dead load, no ice cases, for n phases we are having 11.85, and for mid phase it is minus 12.85. So you can press Shift V so that the value of load can be visible on the screen. So now we can minimize this Excel and maximize our STAAD.Pro. So we are going to apply all the loads here. So this -3 we can apply at any of the node and the tower top. Sorry, it is wrongly. Yes. So if you are going to select the node wrongly or you can again select this, because we are selecting this toggle load. So if it is a toggle load, means we can switch on, switch off any load. One time if we select, means the load is applied, load will apply. The next time if we select, means the load will removed. So that is the main purpose of this toggle option. And finally we had applied all the loads. So now we are going to define the two things, the self-weight of whole structure and the wind load, that is a extreme high and a moderate wind load on structures. So now we can display whole structure. You can select this self-weight, select all, assign to view, assign, OK. Now you can notice here that question mark in red color also removed here in self-weight for dead load without ice. Similarly, like we need to do it the same thing for dead load with ice also. Control A for select all the members. Click assign to view and assign. Click yes. So now we can see. So we had applied the self-weight of whole structure and all the conductor loads and earthware loads that include both wire tension and dead load and various wind load. Now we are going to apply wind load on structure. So for that, go to the load and definitions. In the definitions, select the wind definitions, click new. In the definition tab, go to wind again. So in that type number 1, we need to mention the extreme wind. Extreme wind for 0 and 90. Code European standard we are doing, but it is not listed here. So we can select as custom, enter. Similarly, like extreme in 45 degree 1 and high wind 0-90, high wind 45, moderate 0 and 90, similar like moderate 45. So there are these are the 6 definitions, wind definition we have to have for as per our load calculation requirement. So you can see on the right hand side an Excel sheet which is showing the calculated value of wind on structure. So these are the 6 forces we need to define in the wind definitions. So the first case is extreme wind 0-90. For that the wind pressure PD is 2.57. So double click this, add here. So intensity we need to add it here as 2.57 and the structure height we know it is a 21 meter. Add the exposure factor, we can consider the drag coefficient. So for the exposure, we need to select all, click assign. So all the nodes are selected here. So these are the expose factor, exposure range. And similar like for type 2 also we have to define the similar like what we had done here. That exposure detail we can delete it, which is not required, because we are going to define here a dynamic drag coefficient factor also. So there is no need of exposure factor to be defined. So only intensity is sufficient to define this wind. So all the 6 we have added the intensity here and the respective height of the structure. So 1.54 is for moderate wind as at 0 and 90 degree. So we had defined those, and we are going to apply the wind load on structure under respective load cases. So extreme wind 0 degrees start from here. Now we can maximize this STAAD.Pro. Yes, in this extreme wind we need to add wind load. So wind load, in that regular we need to select. There are 6 types which we had defined earlier in this. So these 6 types are showing here. So first one, regular, we are applying. In that X wind phases we are going to apply. In our case, that X means it is a parallel to a conductor span. We have to decide as we are having Z as the direction parallel to span of conductor. So we can select Z first. So for the load case 9, 0 is Z direction. So the factor we can consider 1. We know that minimum range start from 0 and maximum range of height is 21 meter. And we also know the X direction, it is 0, start from 0 left side, and towards the right side it is 21 meter. So let me measure those. Go to utility, click node to node distance. So these are our distance. So now, so instead of 21 meter we can give 22, just little bit higher than the exact value which we are having. And X direction it is 3 meter. No, it is 18 meter. So 0, instead of 18 we can give little bit higher, 20 meter, and define in Z direction we can consider 4 meter. Add. Also click this open structure, click add. So you can close this, and now we can select here. You can see the loads are applied. So similar like we need to apply for 45 degree extreme wind also. So click that, add, go to wind load, X direction. Here we need to apply for both the direction. So we need to select the second one, 22, 0 to 22, 0 to 20, 0 to 4, XY. Open structure, add. Similar like for Z direction, add, close. So you can see here the wind load in both the direction are added. For extreme case 90 degree, we need to add the wind load in X direction. For that, first case to be considered. Same like previous, open structure, add. Now you can see here the loads are applied. So in order to view the load direction exactly, you can click here, right click on the screen, go to structure diagram, that load, scales, click approximately and minimize this scale so that so you can see here the load direction of wind. It is in a 90-degree, that is wind perpendicular to the conductor span. So similar like if you select for load case number 9, so you can see here this wind is a direction parallel to conductor span. So in 45-degree we are having both the directional wind. So similar like we need to apply the same thing for high load, moderate wind loads. So finally we had added all the structure wind loads, moderate and high wind in 45-degree, 0-degree, 90-degree, moderate wind 0-degree, 90-degree, 45-degree and extreme 45-degree. Only thing that selection of cases is a thing, because here in moderate wind we need to select the wind load cases. Here is 5 and 6 respectively, and for high wind it should be 3 and 4. So likewise we need to select as we had defined earlier. So high wind is for 3 and 4 and moderate wind 5 and 6. For extreme it is 1 and 2. So next, so now we need to define the temperature load, the minimum temperature load for structures. So select all the structures, add temperature. Here we need to give the temperature change for axis elongation, that is minus 40-degree. So minus 40-degree we are adding here. Assign to view. So now the temperature load for structural members are added, but however we need to remove the temperature load applied on the dummy member. Click on utility, go to command, so we already defined the dummy member numbers which are start from 2001. So this we need to remove from the, these are the members we need to remove now for minimum temperature load case. So this 2001 to 2004 we can remove now, and similar like for 2197 we have to remove. So for that we can enter here 204922196 and 22012. So now the dummy members are removed. You can also check those. So the dummy members are not selected. For dead load case also we had selected including the dummy member. As for the dummy member, we had defined already the 0 values, so the self-weight will not be considered by default by the STAAD program. So these are the primary load which we had applied. Next we will look into the load combinations. Thank you. Look description for more related videos. Subscribe to this channel for more updates. Thank you.